.890 pounds, and we say this was a compression. We said it's compression. I'm still doing the same voice. Cannot believe it. This video is so long. Farewell. I'll see you all tomorrow. Adieu, adieu to you. Sound of music. That's what it is. I think I'm gonna move on to the force at E. I think so. Yes. Very good. Very good. Okay. I think I'll move to joint E. Joint E. So that's that. Joint E. I draw that. That would be we have that. We know that to be 38.890. So that's good. We have some kind of force here. Oh, I know something. And then some force there. Now look at this. Remember, we're always thinking about the sum of the forces in the x direction equaling 0, and the sum of the forces in the y direction equaling 0. So, if we take a look at this, we have an x direction force and an x component force from this. Well, those are the only two component forces. I mean, two x forces. So that means this x force has to be pointing that way, which means this force has to be pointing upwards. So, and then we'd have a component force pointing upwards, and that means the only, because this is a y component, and the only other y direction force is this, and it must counteract it, so we have that pointing down. This will have to be the same as that, and this will have to be the same as that. So, look at this. We already know this one, which means we already know that one. So this is, what is that? That's the ECX, right? This is the force within EC in the x direction. That has to be 38.89 pounds. Let me just add my directions on this. This was pointing up, which means that has to point down, that has to point down. This is under tension. And then we have that pointing up, this is pointing down, so that's under compression. Because it's pushing on the joints, it's under compression. It pushes back. So, cool, we have those directions. Now let's solve for stuff. If I wanted to find this, then I need this angle, correct? So I'm using my actual force and the component force. That's in the x direction, 38.89. And I have a y component force. I'm not concerned with that right now. I want FEC. So I need this angle and that angle. I'm going to go to the distances, so I'll make another triangle. That angle is the same as that angle. So to find that angle, I'm just going to use this triangle. Then I'll go back to the forces and the components. So that triangle was 7 feet for the base, 6 feet for the altitude. So this is 7 feet and 6 feet for the altitude. So to find that angle, I will use tangent of, I'll call that theta 2. So tangent of theta 2, that will equal opposite 6 over 7. And then do the inverse tangent, just like normal. We do the inverse tangent, 6 over 7. And that gives me theta 2. And theta 2 then is 40.601 degrees. So there we go. I'll go back to this and I'll say, I want cosine, right? Because I have adjacent and I want the hypotenuse. So I'll use cosine of whatever I just found, 40.601 degrees. That must equal 38.89 over FEC. And I will switch those two. And I'll put it in a calculator. And FEC equals 51.221 pounds of force, and we said it was under compression. So EC, I just found that. 51.221 pounds under, what did we say, compression. So there we go. That's sweet. Maybe I'm not done with joint E. Yeah, I'm not done with joint E because I still need, what do I need? Do I know this? Do I know that? What is that? What is it? Answer me. That's BE. Do I have BE? I do not have BE. So, well, that means I just need to get this force because that's the same as that. So let's do that. We already have the angle. That force is right there. So that's what I'm solving for now. So I use that same triangle. Except for now, I'm looking for that, which is FECY. And the reason why I'm looking for that is because FECY is going to be equal to, but opposite in direction, equal in magnitude, to FBE. That's what I'm looking for now. So it's going to be equal to FBE. So FECY, that angle was still 40.601, and we have 38.890 there. So that means we can just use what, tangent? Tangent of 40, the angle, 40.601 equals FECY divided by 38, I can't fit it, 38.890, so that means FEC in the y direction equals, I'll just multiply both sides by 38 and then get my answer. So that's 33.334 pounds. That means this is 33.334 pounds. And BE was under tension? Yes. FBE. What did we just say? 33.334 pounds under tension. And, wait a minute. Do I not have AB? Oh, AB was 0 pounds. Right? Yeah, we crossed it out. Cool. One more. We need BC. Oh, we have EC already? Yeah, we need BC. Sweet. So here's the thing that people confuse sometimes. We have this, right? We have this angle. We have this force. And they're thinking like, oh, that means we can use SOHCAHTOA to find this force. Incorrect. Remember, you can only use SOHCAHTOA to find forces like using their components or finding component forces using the regular force. And here, this is the force within this member and the force within that member. You can't use SOHCAHTOA for that. So you can't use SOHCAHTOA strictly to find forces between members, only between the actual force and the component, or the component and the actual force. So, let's see what we can do. Maybe I'll look at joint C. Yeah, I'll look at joint C next. Where do I have room? Not very many places. Oh, lots of places. Okay. Joint C. Chauncey Billups. So here we go. 51.221 pounds. And okay, so that's joint C. I need this, and it's in the x direction, so I need to sum up things in the x direction. Okay, so what do I have in the x direction? I have this x component, I'm going to do it in red, this x component, and the 100 here. This has to balance it out, right? So this definitely has to go in the left direction. So we can change stuff here. So that's to the left, that means that's to the right, and this is under tension. So let's see, do we have, what was that force? EC. Do we have EC in the x direction? If we do, that's easy. Where am I going? This is FEC in the x direction. FEC in the x direction. I'm going to undo that. It looks bad. It looks like I'm saying it's 51, but it's not. So here, I'll do green. That's 51.221. Okay. And then in the red is FEC in the x direction. I think we have that. Do we have that somewhere? FEC in the x direction. BD, FEC, FECY. Oh, there it is, right? FECX. 38.89. Sweet. FECX 38. So this is 38.89. And that's going to the right. So all total to the right is 138.89. So that means this must counter that. That's 138.89. Nothing fancy. We're done. We're done. We're done. We're done. And that's the force within BC. Yeah, 138.89, and that was under tension. We're finally done. Good night.